Welcome to Chillin' 101. We hope this video helps.
You begin by setting units to millimeters and creating a new component so geometry matches vex parts. This avoids scaling errors later. Once done, open or build a parameter table with hole sizes, shaft diameters, and plate thicknesses, because parameters let you update every part quickly. Immediately import the vex part library or model a standard motor and wheel as reference geometry so you can constrain parts accurately as you sketch and assemble. You now model parts parametrically. Sketch profiles on the correct plane, reference your parameters for exact hole and plate dimensions, and extrude features with intent. Once parts exist, create joints rather than manual constraints so motion behaves predictably. Use rigid groups for subassemblies and slider or revolute joints for shafts. Additionally, use mirror and pattern features to replicate repeated vex parts quickly, and mark components as adaptive when designed to fit around other geometry. To finish, assemble everything with final joints and run an interference and motion study so moving parts clear correctly. This prevents surprises during build. Once validated, export DXF for CNC or laser cutting, STEP for team sharing, and SDL for 3D prints. Make sure coordinate systems match your fabrication tool. If parts bind or holes misalign, adjust the parameter values that control those features. Reapply or reorient the joints, and rerun the interference check to confirm the fix.
Thanks for watching. Consider subscribing if we helped you.